Hello guys and welcome to video 4 of the Fusion v Alibre series. We'll be discussing the sheet metal environment. And without further ado, let's get to it. Okay, so I don't have a real part, if I'm honest, but I'll just create something so that I show you the different tools and how they work together in Fusion and Alibre, and we will be starting with Fusion this time. So let's get a center rectangle going. Let's do this 100 by 200. And let's make our first tab. So Fusion has this multifunctional flange tool that does most of the work, right? Which is a different way of thinking about things, but it's not necessarily bad. If you get the hang of it, it's pretty okay. So we made a tab. Let's just show you how the sheet metal setup works in Fusion. What you have is you've got pre-made sheet metal rules, right? You have steel in millimeters, and these are the numbers. You've got steel in inches, aluminum in inches. This is pretty good actually, right? This is pretty useful. And the way this works, so now we're using steel in millimeters. You can click that little pencil and you can change it. So let's do 1.25 millimeters. K factor is fine. Bend radius equal to the thickness. Let's do round reliefs. And yeah, okay, cool. So this is set up. Let's hit OK, and you saw the thickness change immediately. And if we go and measure this edge now, it's at 1.25. So we got that one. We got that one down. Let's now go and let's go make a flange here and get at 70 degrees. If I am honest, I do like the handles here. So height of 60 at 70 degrees. I want the outer face measure and I want the bend on the inside. Yep, that's about right. And I hit OK. Then I will go and make these 3 flanges. And now I want to have this at the same length exactly. So this was 70 degrees, so I've got a 20-degree included angle here, right? Which means that if I get a right angle triangle, and if my hypotenuse is 60 millimeters, then the vertical side that is adjacent to my 20-degree angle is going to be the cosine of 20 degrees times 60. You can see this lines up very well. So let's say now that I need to move these flanges and close this corner, we have the corner closure tool, and if I select this edge and this edge, it just brings it in correctly. Oh, yeah. Okay, and I need right click drag upwards and you repeat that command, and let's say that this is the box I want to design. Okay, now I will create a flat pattern for it. Say that this is a stationary face. We've got our flat pattern, finish our flat pattern, and a nice thing you can do here is that you can do a DXF export directly from here, although that will not give you bend notes. So it's still better to do it from a drawing. And I want to demonstrate one more thing. Again, this is not very realistic, but let's do a 40 millimeter here. A 40 millimeter flange here, and let's say I want to do a sketched bend. So I will sketch here, say that this is my line. Now sketched bend in Fusion is called a fold, right? So this is how you do that. This is your stationary face, and this is my bend line. Okay, and you can do center. That's how you do a sketched bend. And now I want to make a dimple or the relief that a punch would do in the sheet metal. So that is not available in Alibre. It doesn't have a tool for that. So what you need to do is you need to actually design it, which is what we're going to do here. Let's do a rectangular relief. So this is going to be 35 by 60. Okay, so we need cut that all, and then we need to fillet these corners. I found it. Blind. Okay, that's cool. I want to fill it by the thickness. Yeah, I know it's used the thickness in the value for D1, so I'll just do that. In fact, let me do 4 times that, which is, I guess, better for a dimple. And now, in order to do the relief, I need to go and create a new sketch here, and I will use the slice function, which gives me an instant section, and which works great. So, I don't have, I need to project this in. I'll select it, project include, I'll hit project. Oh, I could have hit P. I need the specify entity, I hit OK. Oh, get a 3-point arc. I'll start it from here, right? I want this to be 90 degrees. So I do this, and I'll do a line down, do another arc. Okay. Say that these two arcs are equal, and let's say that this is also twice the D1. Let's change this back to D1 and let's do this 3 times D1. Okay, and we've got like and here. Or can I do a thin sweep? I wonder. I'm pretty sure I can do a sweep. I want this to be my path profile. This. Oh, pretty sure I could do a thin sweep. Yes, I need to do a surface sweep and then thicken it. We need to go back and we just need to not be lazy here. Just edit my sketch and do this properly, right? Well, of course, Fusion does have parametric offset, which is not in Alibre doesn't have that. It should be coming to Alibre soon, but it's not there yet, so Alibre doesn't have that. So now I have this sketch which I can do a solid sweep because it didn't have the thin sweep. So this is my profile and this is my path. This is roughly what you would get from a punch. I mean, it's good enough for what we're doing right now. Let's see if let's go into sheet metal. Let's see if it will flatten it. Wait. I've got the flat pattern here, so I just hit activate. It's coming back to me. So it did flatten it. We've got all of our bends. They're showing correctly. So we got our punched cut over here. And of course, if you don't want to cut off the bottom, you just do another extrude and you plug it. And finally, we will do a cut here. And we're going to cut a circle of 30 millimeters and we're going to cut all the way through. So we do not have sheet metal extrude. If I do that, I want to go through all. Okay, let me get that profile as well. Hit OK. Okay, so we have our cut here. Cuts in sheet metal are very particular. Let me get my flat pattern going again. And if I look at it from the top, you will see this is a slant cut. It's not a straight cut. Okay, so SolidWorks and Alibre have an option in the cut command that says cut normal to, and this is really important in sheet metal if you want to get everything as is going to be produced, because you need a 5-axis laser to actually get this shape exactly like that, and there's no real reason in a box like this to do that. So yeah. First thing that Fusion cannot really do in its sheet metal environment is cut normal to, which is a pretty big omission. And the other thing that I haven't found in Fusion sheet metal is I want to select a face and then round every available corner. And to my knowledge, it only has the normal fillet, which means that if I select this, it just goes on and selects every tangent face. And if I do then 1 millimeter, it becomes a mess. If I want to round these corners, I need to select those edges, then do 1 millimeter, and now it will, let's do 5 millimeters. So we can actually see that. Okay. So let's say that this is our part, right? It's a box for something. I don't know what it is. Again, I was actually looking through the commands a tiny little bit, but this is what Fusion offers in its sheet metal environment, and it's pretty good. So now let's go and make that same part in Alibre, and I'll save this first. Make the same part in Alibre now. Okay, so starting a center rectangle, and that was 200 by 100, and I will use my context menu up here and just create a tab immediately, and that's my first tab. Now in Alibre you do not have a library of sheet metal parameters. You need to set each part differently. If you do actually want to have a library like that, what you can do is what I do in my Total Toby entries and qualifiers, which is make an empty file with nothing drawn in it, but with your parameters preset. So that's one way to do it. And we're going to set the stock thickness to 1.25, just like Fusion. And we're going to set the K factor to 0.44, just like Fusion. And I want my global bend relief to be rounded, and that's it for now. So I will start with my flange on the side here. Should have a handle, but I don't see yet. Oh, there you go. If you get it going a little bit, it appears and doesn't jump to increments. It goes very granular here. So let's say that this is 60. Oh, wait. This was 60. And I don't have a handle for the angle, but I can just go in here and call that 70 degrees. That was on the inside, and that was the outside for the flange length. And oh, I need to dock this. And yeah, this is that flange done. Now I'll go ahead and create these 3 flanges at the same time at 90 degrees. Okay, and I will miter them like so, which is the same way they were mitered in Fusion, and I'll hit OK. Now in Alibre, if you make a flange out of more than one edge at a time, you do not get a sketch so that you can manipulate each flange. However, for this flange that we did on its own, we do get a sketch which we can come in and manipulate. So if I delete this parallel and this vertical, and I go the other side, this vertical as well, you see that I can now make a flange like so, right? Which is not an option in Fusion. Of course, you can do a cut, you can manipulate it with direct editing. There are multiple ways to do this in Fusion, but you simply don't get a sketch to do it like you do here. Let me just put this back to how it was. Okay. And of course, we will need to close the corners here like we did in Fusion, and we have the closed corner tool. I will select this edge and this edge, and you see that the close tool throws an error if you try the alignment to be as a butt joint. It won't do it like that. It won't do it like that. It will do it like that. The reason is these flanges are all aligned to the inside, right? So Alibre is telling you basically that if I extend this to close the corner, it cannot do it because it's on the outside. If you do want a butt joint, you need to change these flanges to be adjacent bends, and now it will give you the option to do it. So there you go. So what Fusion did there, in order to close that corner, is it receded this back flange on its own, and I guess that's some good manufacturing intelligence there. Close that one as well. And of course I forgot to adjust the height here with my with the equation that we did in Fusion as well, and that equation was the cosine of 20 degrees times 60 basically. Doesn't like that. Why doesn't it? Syntax not valid. You know what I think? I think it doesn't like the degrees here because I know for a fact that it takes radii there. So A2 is my angle in the flange. If I come in here and just say in the parenthesis 90 minus A2 times 60 millimeter, 90 millimeter, 90 degrees. No? Yeah. So instead of the cosine, I do the sine of the other the opposite angle, the sine of A2, and it's the exact same value. And let's go now, and this looks a lot better. This closed corner was left over from before. Okay, let's do the flange on the side here now. Do it on the inside. It needs to be 40 millimeters. Okay, yeah, that was about it, 40 millimeters, and I'll do a sketch bend now. So if I remember correctly, if I start the sketch bend, I also get put directly in the sketch environment, right? And I can go ahead and start sketching. Let me delete that preview. So this is my line here. I'm going to project this in. I'm going to tell it that I want my line centered there. Okay, now the alignment was centered in Fusion, so I'll do the same here, and bends the entire part. If I click here other side as tab, I get the exact same result I did in Fusion. So there you go. That's that. I just have Analyze Sketch on automatically. It told me that my sketch was open. Of course it is. It's just a straight line. So that's my sketched bend. Let's go make that dimple now. And this is where things start becoming a lot different. Oh yeah. Well, first of all, because I got the numbers wrong. That was 35. So I make a sketch here and I have it selected, and Alibre has a dimple tool. And of course, this doesn't work, right? Why doesn't it work is because these corners are not rounded. But I have a toggle button here. It says round profile corners, and I'll do thickness times 4. And if I don't want a rounded transition, I get my preview here. What was my depth? Let me see what my depth was. So my depth was 3 times the thickness, and now it can also do a rounded transition. Right? This is my punch relief. And of course, in Fusion, we had the bottom cut out, and I have a toggle for that, and I just click cut out. And if you look, it produces a lip here, an edge that is a bit more a bit closer maybe to what you might see in manufacturing. And oh wait, this is how I did it in Fusion. I cut inside that profile, right? Oh yeah, inside align. Okay, so that's inside alignment. Okay, so that was okay. And you know what, guys, I even have a draft angle here, which I can take to 3, 4, 5 degrees, 6 degrees. Look at what happens, right? It's like my punch had an angle, and actually 3 degrees of angle is pretty normal for the punch to be able to retract without dragging on the material, and so on and so forth. I'll just do 0 because that's what I did in Fusion. But yeah, so that's the Dimple tool, and the cutout is just a toggle. Okay. And finally, let me round off those 2 corners up here. In Alibre, you get dedicated corner round and corner chamfer tools. By the way, you also get the regular ones, right? Which is what happened in Fusion, and the exact same thing happens here. Doesn't know what to do with it. But if I go into the sheet metal environment and do a corner radius, and I tell it to round out this face with a corner round of 5, just what it does is it sees that it finds only the sharp corners of that face, 90 degrees or at other angles, but it finds only the sharp corners, and then it goes ahead and fillets it, so which is great. And finally, what I forgot to do is my cutout. So I will just bring this in as a reference, get my circle going here of 30. Right? And then I will open my context menu and do my sheet metal cut. And let me just show you that you get a different cut for sheet metal, and you can also do the normal cut, which is here, extrude cut, but this is a sheet metal cut. Right? And what it will do is it will correct the exact problem we found in Fusion, right? So you can clearly see here that this cut is normal to that face. And when I go and do my flat pattern, if I highlight it and look at it from the side, this is not slant. Right? This is a normal cut. If for whatever reason you want to do the cut exactly like we did in Fusion, because for some reason you do want it like that, and you do have a 5-axis laser, you can still do it. That's it. Let's see if it will flat pattern it, and you do get your slant cut here, right? But this is not something that you can easily manufacture. So the correct way to manufacture a cut like that would be with what you would get from the sheet metal cut. So yeah, this is our part. In summary, I would say that Fusion has got some great tools for sheet metal. It's got a lot of manufacturing intelligence. So Fusion did perform slightly better in the closed corner, but on the other hand, you do not get exposed sketches for the flanges. You do not get corner round tools that fillet or chamfer all of the sharp edges and only the sharp edges of whichever face you select, and you do not have dimple tools. And let me tell you, the corner round and the corner chamfer tools in sheet metal in Alibre are such huge time savers that you would see a noticeable difference here. So that is an overview of the sheet metal environment. Alibre, being one of the oldest CAD software, has an amazing sheet metal environment. It is very, very complete, and As you can see, you can do lofted flanges, you can do contour flanges, you can convert to sheet metal. The tooltip just does a great job of showing you what that actually is. But as a high level overview, I just wanted to show you some basic tools that are missing from Fusion and that are already in Alibre. And I should note that sheet metal in Alibre is only available for Design Expert at $2,000 of perpetual license. But based on the economic analysis in the first video in this series, that is still a better value proposition in a 5-year time frame. Anyway, right? So I still maintain that it is better to use Alibre design for parametric mechanical design than Fusion, and even the sheet metal environment is better in Alibre. Okay, sound off in the comments, guys. You might want to tell me that I suck at Fusion sheet metal. You might have different workflows to suggest to get the same result in Fusion. I'd love to hear how to do the normal cut to face, how to do the dimple a bit better in Fusion, and all that. If you like this video, hit like and subscribe, and I'll catch you in the next one.